Hello. In this video, we want to find the intervals for which the following function increases and decreases, and then we want to graph it, and we'll do that on the calculator. So f of x equals x minus 1 all over x plus 1. Well, to do that, we want to first find the critical numbers, and to do that, we want to find the derivative of f. So f prime of x equals what? Well, since this is a quotient, we'll use the quotient rule, which is the bottom, x plus 1, times the derivative of the top, which is 1. And then minus the top, x minus 1, times the derivative of the bottom, 1. And then all over the bottom squared. Excellent. Now, notice that here, x plus 1 times 1 is x plus 1, x minus 1 times 1 is x minus 1. So this is going to give me x plus 1 minus x minus 1 all over x plus 1 squared. And you can distribute the negative if you want. And that's going to give you x plus 1 minus x plus 1 all over x plus 1 squared. Notice that the x's cancel each other, and so as a result, you're going to get 2, and then all over x plus 1 squared. And this is the derivative. Wonderful. Now that we have that, though, we can find where the critical numbers are. We take the numerator, set it equal to 0, and then take the denominator and set it equal to 0, and solve. The first one, there are no solutions because 2 is never equal to 0. For the second one, though, there is a solution. That's x plus 1 is equal to 0, which means x equals negative 1. But that's only a critical number if it's in the domain of the function. Notice that if I put this in the function, negative 1 plus 1 is 0. So we're dividing by 0, and that's a problem. So this technically is not a critical number. However, because it isn't part of the domain, it still can break up the number line itself. So the 1 is not a critical number. Sorry, the negative 1 is not a critical number, but it is still an important number. So let's choose numbers here. To the left, we are choosing x's and then f prime of x's. To the left of negative 1, let's just say it's negative 2. And if you plug that in down here, negative 2 plus 1 is negative 1. Negative 1 squared is positive 1. 2 over positive 1 is 2, which gives us a positive 2, aka it's positive. Now, a number to the right of negative 1 would be 0. Plug that into the derivative. 0 plus 1 is 1. 1 squared is 1. 2 divided by 1 is 2. And again, that's positive 2. So that's plus. So what this is telling me is because there aren't any other possible critical numbers. Notice this isn't technically a critical number, but it is an important number still. This function is increasing on its entire domain. But remember that that domain is only where the denominator here is not equal to 0. So the domain of this function is where x plus 1 is not equal to 0. So x is not equal to negative 1 here. So as a result, we are increasing on negative infinity to negative 1 union negative 1 to infinity. And there we go. Excellent. This function is never decreasing. So as a result, we need to go ahead and figure out, well, what's that going to look like? Well, that means that we're going to have to graph this, which means we need to go to the calculator. I'll see you there. Okay, so welcome back to the calculator. Let's go ahead and type this in. So on y equals, we're going to do alpha y equals enter. And then in the numerator, we're going to type in x minus 1. And in the denominator, we're going to type in x plus 1. Excellent. And then graph this on the standard window. And here you go. Now notice that the x equals negative 1 is a vertical asymptote here, because that's where the denominator is actually equal to 0. And that creates a vertical asymptote. Alrighty. By the way, notice the function is increasing going this way, and then it's increasing here as well. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.